For our last session of the day, I'm happy to introduce Kaggle's very own Dan Becker. Dan's a data scientist with a PhD in econometrics and serves as the head of Kaggle Learn. Dan will be doing a little bit of his own introduction here in a moment, but in the past year and a half, he's helped create over 10 data science courses on the Kaggle platform. Dan, like me, is from Denver, Colorado, and he's not doing or teaching data science. He enjoys skiing, climbing, and playing tennis. And a fun fact, he's referenced in an episode of the TV show, The Office. Dan, I'm gonna hand things over to you to help us understand how might skill building be holding us back. Dan, take it away.
Okay, so before I get started, this is a topic which I think is transparently from the title, many people will find counterintuitive. Some people may even react pretty negatively to it. So before getting started on the topic itself, I just wanna give a brief heads up on the experience or the data from which I'll be drawing, so you can figure out whether you wanna believe me or not. So I got a PhD in 2009. By the way, so getting a PhD is not any part of why one should believe me, and that's not a piece of data at all. But I did spend a year or so after that where I got a job working for the US government, but I was looking to live in a specific geographic area and spent a long time trying to find a job as a data scientist. Really struggled with it for a while. So I have been through the data science job search experience. In 2010, I had the hypothesis that if I started competing in Kaggle competitions and did well, that would advance my career and help me find the job I was looking for. I had the good fortune to do well and get to test that hypothesis, and it worked out really great. I finished in second place in a competition, and as a result was contacted by a large analytics consulting company that hired me directly to do a few things. So first, create trainings for their analysts or their consultants. Second, to help them build out their capabilities. So in that role, I interviewed hundreds of junior data scientists and data scientists, and then also to talk to their clients. So I got to see inside the data science and analytics departments of quite a few large companies, disproportionately in the US. I think there are 5 companies in the Fortune 500 that I worked with and got to see how they think about data science, which has really, I think, given me a lot of perspective on the field as a whole. In 2015, I taught a data science boot camp. This was a 12-week course where I taught people who had not done data science before how to learn data science and how to do data science. All of them got placed in jobs, typically pretty good jobs. So some at large companies like Amazon, some at small companies like a startup that's doing deep learning for radiology. But I've had the good fortune to see their progressions and not just in their first job, but I stay in touch with them. And so it's another way that I've gotten to see different ways that people grow as data scientists. In 2017, I joined Kaggle and started Kaggle Learn. That now has between 25,000 and 30,000 users a month who do our hands-on coding exercises as part of our courses, and more than that, who just read and follow along in the courses. And I try to not in a interpersonal way because of the number of users, but I do try and keep tabs on how people are doing. So I think between all of this, I've seen a lot of different parts of the life cycle of a junior data scientist. Probably interviewed in total between all my jobs, probably 500 candidates. And one of the things that I've seen is you have a spectrum of different ways that people approach getting their first or second job in data science. And I'm going to simplify that spectrum of approaches a little bit and talk about 2 different personas which are on opposite ends of that spectrum. So the first I'm just going to call short-term Sal. This is someone who is just looking to get a job, wants to do it quickly. They're going to do whatever it takes to impress an employer, but they're not thinking too far out. Most people I know who fall into this profile are reasonably disciplined, but they're looking for, they have goals that they want to reach in a matter of months, not years. The other end of this spectrum is someone who I will, in this presentation, refer to as long-term Lee. So Lee is someone who is willing to study hard, study things that are pretty foundational, try and develop a deep theoretical understanding, is quite disciplined about it, and has goals of, I want to be a great data scientist and have a great data science job, not in a matter of months, but I'm really focused on where I'm going to be 5 or 10 years out. So if the world was a real fair and predictable place, we would expect their trajectories to be something like this. Short-term Sal would do better in the short term, and at some point, long-term Lee, who invested a lot upfront to get a deeper understanding, would surpass short-term Sal and would have a better long-run achievement. So that would both, in some sense, be both of them reaching their goals. This is, of the people who I've seen, I don't see this pattern, which we would expect at all. And I should say, like, it pains me a little bit, the pattern that turns out to be the case in real life, because I think my personality is a little bit closer to long-term Lee, and that's what I did earlier in my career. But in practice, the pattern that we see is closer to what you see here, where short-term Sal and long-term Lee, maybe they start out in similar places, but at some point, short-term Sal gets a job. However much time they were both spending on learning data science or projects on the side, short-term Sal now has 40 hours above and beyond that doing data science because short-term Sal is getting paid to have a full-time job doing data science. And even beyond that, short-term Sal now has colleagues and a manager who are really invested in their further growth and improvement. And so short-term Sal really, their knowledge improves faster than Lee's, and their achievement, they're sort of always ahead of long-term Lee, who invested in some really like foundational understanding of data science. So, like I said, it pains me that that's the case, but I do think I have a good explanation for why that's happening. So the first part is, if you look at the things that long-term Lee does, they're either studying textbooks, which takes a long time, or they're taking online courses, and most online courses. So I have a couple of screenshots here: fundamentals of statistics, fundamentals of machine learning. These, by the way, are courses I've not taken. I assume they're both taught by very capable and smart instructors. But if you look at them, they so let's look at fundamentals of statistics first. That is 16 weeks, so 4 months, at 10 to 14 hours a week. And for many people who have either other jobs or other commitments or other studies, like 10 to 14 hours a week is hard to keep up. And then you're saying, even if you can do that, even if you can keep up, just this one course is 4 months. The machine learning fundamentals course that I posted here, that is 8 to 10 hours a week for another 10 weeks. So just to finish these two courses is half a year. If on the side you're studying a textbook, trying to learn machine learning through textbooks or linear algebra through textbooks, you're really like quite far out, many months out, where you're still doing things that you think of as fundamental learning. And unfortunately, like, even while that learning might be valuable in some ways, the phenomenon that I see of people who take this approach is they study a ton. They're not really sure when they've reached a threshold where they should feel qualified to start a job. At some point, they say, "Oh, I'm sick of studying and not applying for jobs." So they apply for jobs, and then they hear nothing. And studying these core ideas, not having helped them achieve their goals, they, instead of changing path, they instead say, "I'm going to double down on studying. Maybe I just didn't study enough." And so they just repeat this cycle. And I know people who have gone through this process for literally years, which at the end they're pretty frustrated, and I think justifiably so. And from the outside, like, it's quite disappointing to see talented people working hard and achieving so little. But I understand, having hired quite a bit, I understand why they're achieving so little. Primarily, their resume is in a stack of quite a few resumes. So of the times that I've hired, so let's see, there was one point where we were hiring for 5 or 10 open positions, and we got over 1,000 resumes. So if you've taken some MOOCs, like, are you going to get noticed in a stack of 1,000 resumes? Or if you've read some textbooks, like, is someone going to say, "I think this person really stands out"? No, it's just, you're just going to get lost in the shuffle, and that's what happens. And so people can be going through that cycle, getting lost in the shuffle for a really long time, which, like I said, is quite frustrating. I want to. So part of it is that you don't get noticed because it's a crowded space. There is a second part of it. And this will be like the one data science brain teaser that I will walk through in this presentation. There is a part of it that is where companies are justified in not finding those employees and putting them at the top of the stack. And that is because there are certain skills which just aren't taught well in textbooks, tend not to be taught well in MOOCs, and are like super practical skills that are important. You learn them doing data science, um, but there's not like complex linear algebra to them. And as a result, they just seem to get glossed over in most treatments and in most courses. So let me give you an example. So when I was teaching that 12-week long boot camp, this was an example that came up. We had data from a ride sharing service. The ride sharing service wanted to build a model where at the beginning of each month, they could predict who's going to keep using their service in that month and who's not going to use it. So they set up the data so each user shows up in their data only one time. And then they have something we want to predict, which I've listed here as continued use. It's either true or false. You have a bunch of predictors or features. These are shown as ... And then we have one particular feature, which I'm going to show you, I'm going to go into in the next slide, which is the average rating that that particular passenger from that row gave to the people who drove them as part of that ride-sharing service, like Uber or Lyft. Okay, so the phenomenon that we saw is shown in this slide, and this again is not the real original data, but it shows the relevant phenomenon. And I'm going to tell you what I see here, and I want you to see if you can figure out what's causing this. So what I see here is if you look on the graph on the left, this is a histogram of average scores for each of the passengers who stayed. So those who continued using the service in that raw data, we see that a lot of them gave their drivers ratings that were sort of in the middle of the distribution. If you look at users who quit using the service, you see, yes, a lot of them gave ratings that were in the middle of the distribution, but you also see some that are at the bottom of the distribution. That's this one. And you see a good number who gave ratings at the top of the distribution. So of users who gave very low ratings, that's the users who rated at 1. They rated their drivers 1 on average. Like, it's understandable that they quit. All their experiences were bad ones. But it's kind of puzzling that that we have a high, to say an average rating that's towards the top of the distribution, that's this 5, that's actually more common for people who quit the service than those who stayed with it. Okay, so that's the puzzle. Like, what do we think is happening there? This is something that you can take. I took PhD level stats courses, and I certainly didn't learn how to think about this problem and what could be causing it as part of PhD level stats, where we're doing all sorts of integrals. But if you've done a lot of applied data science, this sort of thing can pop out at you pretty quickly. So hopefully you've had a chance to think about it. And what's happening here is that users who continue using the service, those on the left, they have a lot of ratings. And if we weren't careful about how the data was prepared, some of those could be ratings from after the period where we were trying to predict whether they would quit or they would stay. Those on the right, they quit using the service. They frequently have only 1 or 2 ratings. And so it's pretty easy if you have a small number of ratings for those to be at the top or the bottom of the distribution through something which is sort of roughly a law of large numbers phenomenon. Okay, so here's the part that's important. To the extent that this hints that the data may be changed after the thing we want to predict, that is something called target leakage. And I won't go into all the technical detail because we're sort of more focused on something that's a different issue than what is target leakage. But when that occurs, that will cause your model to look very accurate when you test it. But then when you deploy it in practice or when you use it for practical purposes in the future, it will be very inaccurate. This is, like I said, the sort of thing that the short-term focused person who gets a job quickly and works on real data science project, they're going to learn to recognize these patterns. And you can do really high-level statistics or really high-level machine learning education and not learn to spot things like this. And so in that sense, I think it's sort of understandable that companies aren't excited about purely MOOCs or, to be honest, purely PhDs. Or certainly aren't excited about the pure PhD with no practical experience, as many of us would expect. So the thing that we find is when we say short-term Sal has this higher trajectory, in part it's because they get to see these practical issues And as a result, they always have more experience where it matters, always have higher knowledge and higher achievement. Okay, so I, at this point, advocated that the long-term strategy of taking these really long courses doesn't pay off. What should, instead of what should you not do, what should you do? Okay, so the short-term Sal has a strategy. First of all, you need to learn, you're going to focus on doing hands-on projects. You need to learn the minimum necessary to have a successful project. I mentioned that I run Kaggle Learn. This is something that we're very focused on in Kaggle Learn. Our courses, I showed you these courses, which took a matter of months. Our courses are measured in hours. They are very, very, very applied, very focused on giving you enough to have a successful project in a given area like deep learning. But at the same time, we're not going to teach you everything because we know that it's important for you to start working on hands-on projects quickly. Okay, so you learn the bare minimum necessary for to take on a project. Second, find a topic that's interesting to you. So that could be a hobby, that could be an industry you want to work on. If you can find data about a TV show that you enjoy, if there's a news story you found compelling, whatever you find interesting, try and build a data science project around that and show it widely. So showing it widely means posting about it on a blog, hosting it in Kaggle kernels, posting it on GitHub, tweeting about it, posting it on LinkedIn. I'm telling you to post it broadly, even though I'm also going to tell you it probably is not going to be that good if you're not that experienced, and that is okay. You're going to have one of two responses. Either people will tell you they think it's not that good, and ideally they'll tell you why. When you engage in those conversations about how to improve your work, you're going to learn very, very quickly. And in some cases, it'll be something that you can just change something very quickly, and that'll be easy, a great learning experience. In other cases, you'll realize, I don't have the theoretical knowledge to do a great job on this project, but I learned that from my interactions with others. And you may end up taking a short course or looking something up in a textbook. You will learn theory, but you're going to learn it as needed. That's going to make sure that it's theory that's applied. And in practice, of the people who I have mentored and who I've talked to, I find, and this is actually also true in my experience, you will find yourself more motivated and you'll find more time to keep working on learning if it's something that you can contextualize in improving a project that you're excited about. So that's what happens if people tell you that they think the project can be improved. The other alternative is you might find people who really, really like the project, and that's obviously an even better outcome. That's a starting point for networking. If you find people who say it's a great project, let them know that you're looking for a job. After someone's complimented you on your project, they may be inclined to try and make connections for you. They may say, "Oh, we're hiring." And if you go back to that stack of 1,000 resumes, this is how you get to that stack to be either a separate pile, which is only 1 or 2 resumes, or you get to be the top of that pile. So this is really a really important outcome of publishing your hands-on projects. In most cases, your first project isn't going to land you a job because, it's getting your first job in data science is admittedly at the moment a somewhat challenging thing to do. So you might need to build 2 or 3 projects and iterate until you have a portfolio. Why does this work? So first of all, the skills you acquire are very, very applied, addressing things like this target leakage issue that I mentioned. And then secondly is, so this is something that I learned from a friend who isn't in the field of data science, but who hired a professional career coach. And the career coach gave them lots of advice. One of the pieces of advice which always stuck for me because it was the most surprising piece of advice is something that I'm going to call the yellow scarf technique. This is pretty close to the sneaky technique that the others in the job market don't want you to know. So the idea of the yellow scarf technique is that when my friend, when she went to interviews, she was told to do something, not something offensive or something too outrageous, but something memorable. So you could, for instance, wear a yellow scarf. And that way, when everyone who interviewed you, and at this point, they've probably interviewed 10 different people for a single job, when someone says, "Hey, I really liked Sal. I thought they did a great job of of explaining their model. Others will say, wait, who's Sal? And if no one can remember who you are, then you sort of get lost in the shuffle. But if someone could say, oh, that's the person who, when they were interviewing, they were wearing a yellow scarf, it's this sort of memory hook that allows people to remember you, makes it easy for them to discuss you. If you crash and burn in the interview, then they'll probably remember you crashed and burned, but who cares? But if you did well, then this is a way for you to stand out and for them to be able to communicate that you did really well. My friend took other advice from their career coach for a couple months, had some interviews, didn't get any job offers, and then started using this yellow scarf technique. And she got 3 job offers, and I think she said 4 out of 4 interviews in 2 weeks. So it's a very small sample. The data scientists among us prefer larger samples, but I find it compelling, both as an interview technique, but whether it's compelling as an interview technique or not, I think it's clearly the case that, and I've hired people because I thought they did awesome projects and that I would forward their resume to others in my organization. And so I think it is very clearly the case that in a world with 1,000 resumes, if you can have someone browse Reddit and say, this person's work is actually really interesting, that puts you in a totally separate category from someone who spent a year taking MOOCs, even though maybe you spent 10% as much time on it. A really interesting example, which has been widely circulated recently on the internet, is someone was a aspiring data scientist, didn't have a job, but I think had taken some sort of boot camp. They wanted to do a project, didn't have data, so they put their smartphone on the front of a shopping cart and walked around a grocery food store. Took some photos with their smartphone, and then tagged the data to show where the shelves needed to be restocked. So you see that in these red boxes here. They then trained a deep learning model to identify where the spaces that need to be restocked. Which, by the way, so I find this an interesting project, and it has this like nice visual to it. But the underlying thing that they're writing about, when to restock grocery store shelves, is in some ways like the least interesting thing that one could do a project on, and yet this still is like ends up being a sort of interesting project. Yeah, I think it's if you're creative and if it's novel, that alone is enough to make a project pretty interesting. They were, by the way, contacted by the grocery store that they shot these videos in, proactively contacted and then hired because the grocery store was so impressed with their work. That's one example of a success, and I certainly know of others, but I think the visual nature of this makes it really quite memorable. Okay, so that's one project someone did, hopefully is inspiration for you. If you're not going to do exactly that, and you should do something new, what are the things that you need for your project to be successful at getting you a job so that you can be on that steep part of the trajectory? So the first is visuals matter. This favors deep learning because deep learning can work with images, and images are intrinsically visual. But if you want to do something that's not using images or not using deep learning, that's totally fine. But you need to make graphs. Having nice graphs is super important. You should make the graphs. If you blog about it, they should be at the top of your blog. If you post it in a notebook on Kaggle, it should be front and center. Your graph should be beautiful and towards the top of your notebook. If you put it on GitHub, so this, by the way, is a separately quite important point. So in GitHub, you can have these files called readme.md. I'll just call it readme. And that's if someone goes to the homepage for your GitHub project or repository, that's the main thing that takes up most of the screen. It's really important that you have nice looking and clearly communicated README files. That should have a graph at the top, something visual. You will spend hours on your project, and because you spend so much time on it, you think that others will read it in some depth, but that's just not the case. When we look at projects, not only we being me and people who hire, but also probably you tend to scan around, tend to look at it very quickly. So you need to remember it needs to grab the user in the first, 5 seconds or so. Creativity, like this example using the grocery store, and communicating well are important. One of the hardest parts is finding data. Kaggle has data, And so go to Kaggle, kaggle.com/datasets to find data. All that data is freely available. You don't have to pay for anything. And then lastly, browse for others' work. Don't copy it, but it's really hard to sit in an empty room and just say, okay, be inspired, be inspired, be inspired. That doesn't work. But if you look at what others have done, either you'll say, oh, I kind of like what they did for the sport of football, but I want to apply it for cricket, or I think there's some flaw with their analysis, and I'm going to do some analysis that I think improves on it and start a conversation with them. And so browse others' work for inspiration, because that's one way to just come up with project ideas. Okay, so I have told you something that I have seen a lot of evidence is very successful. I'm extremely confident that it will be successful for those who take it very seriously. And yet, unfortunately, I worry that many people will not pursue this at all. And the reason for this is many people who are trying to get into the field of data science have spent most of their life, in many cases, almost their entire life, as students, studying from textbooks, learning from courses, learning theory. And that's what you're comfortable with. That's what you know. It's a little bit hard to do something that's totally different. Many of you have probably never done a real hands-on project and just published it on the internet outside the scope of a course. And doing something new and unfamiliar is hard. And so many of you, despite the fact that I am confident this will be successful if you pursue it, I know that it's going to be very difficult for many people to make that mindset switch away from being a student. But you need to do it. And if you do it, it will pay off. Okay, so hope we have some good questions, and yeah, interested in hearing them.
All right. Well, Dan, we can pull away your slides there for a moment. We want to see you on our big screen here, and also you may have been missing it, but in our chat, there's been a lot of discussion on who's on Team Sal and who's on Team Lee. So there's been a lot of back and forth there. So thank you so much for the time that you have here today. We have a number of questions that have been coming in from a lot of different users. So I'm going to go ahead and kick things off if you don't mind. Let's see, first question that we had that came in was from a Mike Lane. It said, personally, Mike has struggled with the transition from education to business because there seems to be this barrier to entry that's provided by technical jargon, tools, technology, and platforms. So what advice would you have for educators who want to go into data analytics and transitioning into business if they feel like all of their skill sets or all their knowledge may be only what they've learned in the classroom?
Yeah, I mean, unfortunately, this is something that varies on a case-by-case basis. There's some jargon, so there's both on a case-by-case basis due to where they're coming from. There are various types of educators, people who are teaching math or people who are teaching English, and those are quite different from each other, people teaching programming. And those are indeed quite different from business. And that's part of that is short-term Sal, once Sal gets that job, is able to have that steep learning curve in part because of learning the business piece. I'm going to go back to what I said earlier, which is you need to create something that you can share that people will find interesting, which is on a topic that someone can care about. And someone can care about could be restocking shelves. It could be, an example that I saw recently was picking which character was going to die in Game of Thrones. So that's like, by interesting, it doesn't need to be that business-like, but you will find people who like Game of Thrones and also have jobs. And you want to engage with those people, tell them, hey, I'm on the job market, and hope that those people will and go, for that matter, go to, as mentioned, publishing online, but you should also go to meetups and try and present your work as a way to build that connection to people locally. And if they say, I liked your analysis, I found it super interesting, they very likely will help you find a job in your area. So I've said you need to make a project, but even to make a project requires that you make a shift in technology. So if you've never programmed in Python or R before, then you're not ready to write your first project. I personally am quite partial to Kaggle Learn. I think that we have the best approach. We indisputably have the fastest way for you to learn enough to start doing projects. So I would say, the Kaggle Learn course on Python if you haven't programmed in Python before, but then our intro machine learning course. We have a bunch of other courses, honestly, for now, or maybe you could skip machine learning. And if you want to do data visualization, we have an intro data visualization course, but skip the rest of our courses for now. Honestly, that could all be done. Those 2 courses could be done in a weekend or a day and a half, probably. And then find a topic that is interesting to you, and then go through this workflow that I described. You will not learn all the business jargon, but you will learn enough to impress people, and they will be happy to teach you the business jargon once you've shown that you can do interesting data analysis.
It's a great answer, and it reminded me, and I mentioned this in an earlier session, that as a part of our CareerCon, we have a session coming up on how to create your personal brand, even if you don't like self-promotion. And so be sure to stay tuned into that. I think that would be really a great one for you. Dan, that did kind of bring up another question that came in. This one's from Sandeep Singh, and said, in addition to ML, DL, and AI techniques, it seems mandatory to learn LeetCode, HackerRank sort of programming skills. So they're feeling that this lack of skills is a blocker, and the only criterion to hire here, specifically in Silicon Valley. From their understanding, ML and DS learnings are not even asked about in Google and Amazon interviews. Do you agree that programming skills are required to get a job in ML?
Yeah, this is a great question. It varies a ton from employer to employer. So that is almost certainly true. So there may be exceptions, but that is at least 95% true at Google. So when we talk about LeetCode, I'm just going to describe that as algorithms. Google interviews always involve a good deal of focus on algorithms. It varies a little bit from one Google interview. When I did my Google interview, there was probably a little bit less on algorithms because I was coming as a data science educator. But by and large, yeah, Google interviews involve a ton of algorithms, and there's a shift, certainly in Silicon Valley and probably in most of the world, towards more. The businesses are realizing that they need more and more machine learning engineers and less of pure data scientists, where you're doing just what we've described as ML or deep learning. Despite that, I think there's also a huge market for traditional data science, which is not as focused on algorithms. I worked at a company called Data Robot, which built an automatic machine learning tool, or a software for data scientists. The vast majority of our hiring was for conventional data scientists, and we asked no algorithms questions. Time spent on LeetCode would be totally irrelevant for our interviews. So it does vary on the employer. Anyone who calls it an ML engineer is going to be looking for some algorithms knowledge. But there are a lot of analysts and data science jobs where you will not be asked those questions. And unfortunately, Sandeep brought up Google and Amazon. I would say those are outliers in the extent to which they focus on algorithms.
Okay. We're actually getting a number of questions that are coming in on somewhat of a similar topic. And I'll read through a couple of them, and you'll kind of see the theme that's coming in here. Walter Santos said that the single most important question he has is, in terms of skills, generalist or specialist? And we know the answer probably depends, but still want to sort of open up a discussion on that. The next question that sort of came up related to that was, that many job ads ask for a generic quantitative background, and then continue by specifying that they would like someone who's extremely well-versed in every conceivable area of ML, advanced probability, PhD level stats, Python and R. How do you sort of learn enough to apply to these positions without trying to be everything to everyone? And then a final one came from Keytop23. How do you find the balance between quality, how deep you learn something, and amount, how many to learn? So a lot of questions sort of on the breadth and the width. Do you want to talk about that a little bit?
Yeah. So you will frequently hear the advice, which I think is good advice, to have a T-shaped skill set. So the shape of a T, I guess you probably have to turn it upside down for this graph to really work. But if you imagine a capital T, you flip it upside down, then the base is pretty wide. You have some very basic skills in a wide range of technologies, but you have one thing that you are truly specialized in. So it is totally fine if you don't know a lot of probability. If someone asks you about the Poisson distribution, say, I'm sorry, I've focused on machine learning and don't know a lot of probability. It is okay if you cannot, if you can write some Python, but you cannot use decorators, or maybe even like you're not that good at, you've done almost no object-oriented programming, like that's okay for, well, by object-oriented programming, I mean like you've never written a Python class. I'm confident that, I don't recall the specific example, but I'm confident that I've been involved in the hiring of plenty of people who have not written Python classes for data science jobs, but they did know enough Python to get by, to do something productive. And so you need to know some Python or some R. You certainly need to know like mean, median, a little bit of percentile. So you need to know basic statistics. It'd be good if machine learning is not your specialty, you still need to know the idea of validation and should be able to describe what overfitting is. And then you should have one thing that you're quite good at. And to go back to my emphasis on projects, that should be the thing that you focus your projects on. And that it could be data visualization. And you could know very little about machine learning, but know enough to talk to someone about machine learning.
So actually, two questions that we have listed for you that were based off that. One is on the latter part where you said, talking about projects, would you recommend to people who are still trying to get into it, should you take a technique that you want to learn and then find projects that can help you learn that technique, or take a subject that you're passionate about and then find projects to then learn about that subject you're passionate about?
Yeah. Okay. So when we talk about technique,
sorry, that question came in from, I want to make sure I give them some credit, from Purba Hulgal. Correct, yeah. Possible research problems in your area of interest or technologies you want to go explore.
Okay, so when we talk about technologies, we can talk about them being sort of broadly. So a technology is deep learning. Or we could talk about them quite narrowly. So a narrower version of deep learning would be, I'm interested in LSTM networks. So that's a type of deep learning model. I think it is great to say, I'm interested in learning a certain data visualization tool, or I'm interested in deep learning. And at that level of generality, say, I'm going to do something that works with images using deep learning. But then I'm going to find the projects that I can make sure I'm doing something that is interesting to me and will be interesting to others. And I'm going to let the fact that I want to work with images steer me a little bit. But then within that, I'm trying to find an interesting project. I think it's a mistake to say I'm focused on LSTMs, or I'm focused on XGBoost, and I'm going to use like exactly that narrow technology and shoehorn whatever topic I have into it.
Right.
And to be honest, so let's say that you do this. Which characters are going to die on the Game of Thrones TV show? The actual accuracy of your model doesn't matter a ton. Like if it's a reasonable model and you communicate about it well, it doesn't matter whether you used it XGBoost or Random Forest or whatever else. And so in a narrow sense, I think some people get tempted to focus too much on the narrow choice of technique, but it's great to think about what type of data science, broadly speaking, do I want to learn and do I want to do?
That's a great answer. And one of the other ones that came up that was specific to the comment that you're asking about, sort of how do you balance the T graph of skill sets. This is from Edmund Nimsing. Said, hey Dan, I should learn DL and ML concepts using Kaggle Learn. And he uses SQL on the job as a financial analyst and does some more learning on the side. with a couple of public projects implementing machine learning and DL end-to-end under its belt, it finds a lot of openings require skills it doesn't possess, like Spark, etc., or preferred advanced degrees, no master's, no PhD, only a bachelor in economics. So at what point should somebody just stop developing skills and just start applying?
Yeah, let me answer that question, but before I do, go back to a part of the previous question, which was that I didn't answer, which was, what do I do about the fact that, because these are related, what do I do about the fact that job descriptions say that you need to have 4 PhDs and 10 years of Spark experience and 20 years of TensorFlow experience? That you need to you need to accept that. So my PhD was in economics, and I am always sort of intrigued by how businesses work and what are the puzzles in that. It's a puzzle to me that job descriptions are so bad, but job descriptions are so bad they are typically written by someone in HR who may not even know what all these terms mean. And so yeah, there's this barrier of, as long as screening is being done by HR, and who does the first round of screening varies from one organization to the next, but in some cases it is done by HR. It's actually it's a real problem that HR does these screenings and isn't qualified to evaluate or even know whether their criteria are reasonable. But you really need to skip that screen. You need to just avoid the screening of
I guess it is, don't filter yourself out because an application looks like it's
do not filter yourself out, but also know that we get so many applications for every job opening that if you apply through the regular channels, your odds are just not that good. So I may say it differently. I would speculate that for every application that comes in through like a shotgun approach of just, I'm going to send applications through the website. For every one of those, for everything that I find because it's an interesting project and someone forwarded to me, they thought I might be interested in it. For every one of those, I get, I think there are probably 200 resumes that go through like the main channel. And yet the number of hirings that happen through the main channel is probably about the same. So if you're going through the main channel, your odds are just not that good. But also you should, if you have a mutual connection. So LinkedIn has this nice feature of a mutual connection. If you have a mutual connection who could introduce you to someone for a job, but you don't have all the criteria in the job description, don't worry about it. Job descriptions are terrible. Yeah. And some of the most successful, I know a couple of very, very successful data scientists who don't have who dropped out of college. Literally, I could tell you names, and they've been super successful. So don't let
session tomorrow as well that kind of highlights that, talking about how do you get that first interview if you don't have any connections. So we have a great session talking about that tomorrow on getting noticed, which is great. Pranant actually asked pretty much the exact same question. Do the companies actually get people with all the skills mentioned, or they typically have to compromise and recruit people as well? Two final questions for you as we conclude with our time, both getting to our short-term Sal and long-term Lee. And I'm interested once we log off to see what the current voting is on our poll of who is who. One was from Ravi. Ravi was saying, how do those without a strong signal, for example, without a STEM undergrad degree, of rigorous mathematical maturity, prove to employers that they still have the theoretical chops to do the job? So for example, how would short-term Sal deal with the conundrum? Because it seems like the projects that help with the doing part of data science, but do you have any suggestions for crafting projects that demonstrate theoretical know-how that also resonates with employers?
Yeah. So first of all, I'm gonna answer that question. But first, let me say I think many people in the community overestimate the fraction of data scientists who are doing mathematically difficult or interesting things, and instead a lot of it is sort of day-to-day application data analysis. Going back to like that graph, noticing that this data was probably collected for one of these groups after the fact. Okay, but if you are truly really do have great mathematical skill, some of the ways to show that or emphasize that. One is, let me give you some example projects that immediately come to mind. And you don't need to exactly, but these are hopefully inspiration. So in deep learning models, there are a number of ways that when we set up the model, that we can initialize weights. And if you don't know what this means, you can look it up. But anyway, there are a bunch of weights that go into a deep learning model. There are a bunch of ways that we can initialize them using different statistical distributions, and under different circumstances, some of those initializations work better than others. It's not super well understood why that's the case, and at least last time I did any research, it was not well understood. If you were to do this, this is not that relevant for most day-to-day work for most data scientists, but it is something that is a mathematically challenging question to understand. And I think it would be a really interesting project for someone to explore. If someone wrote something up about it and did a reasonable job, I would find it super. If you do that, send it to me. If I think you did a reasonable job, I will retweet. I'm so intrigued by that particular question. I will retweet it. I will repost it on LinkedIn. I'll say, hey, everyone, I know like this is actually like an interesting problem and someone made some progress on that. So you could do something that is widely recommended, but I tend to think is kind of boring, is just re-implementing an algorithm that exists in a standard library like Scikit-learn. But that requires not a ton of math, not a ton of hard mathematics, but a little bit of mathematics and more programming. But you can do a theory project. I think for most people, that's a red herring and a mistake to do something that's that theoretical and not applied. But those would be my first thoughts is understand, or look at for different loss functions, compare how they do in some real applications, and then try and explain the mathematics about why they behave as they do.
Yeah, I think it's great. And then one more of those, I'm gonna leave that to the Slack channel, but a final question for you. I'm trying to ask a lot of our speakers the same question. What's a question that you weren't asked that you should have been asked?
So I have been involved with a lot of different mechanisms by which people learn data analysis. So I immediately after my PhD, I briefly taught at a university, and during my PhD I taught at a university. I taught a boot camp. I've run MOOCs, so I've seen a lot of the different ways that that people learn. And so one of the questions which I think is an interesting one is, for a lot of people, is what are the benefits of each of these approaches? I've become quite disenchanted with the academic path. One, it just takes a long time and it can be expensive, and it can build projects because their data science programs are catching on that's important. They're frequently taught by people who have a nice theoretical background but no industry or applied experience. So I think that is not a great approach. Boot camps, I think, they're widely criticized because all this material is available online for free. I think that's the wrong way to think about it. If it means that at the end of 12 weeks you get a job that pays whatever $100,000 a year, and like you can do that with reasonably high certainty, like that clearly is worth whatever you paid to get into the boot camp. I shouldn't say that. In my opinion, that's almost always worthwhile. The problem that they have is quality control. So I've gone to see the presentations from a specific boot camp which is local to me, and sometimes they do end of course presentations, and they're all awesome. I would hire 2/3 of them, and then other times they're all pretty embarrassing. And so, if you're going to go into a boot camp, you really need to figure out who's going to be your teacher. Try and get reviews not for that organization but for that teacher specifically, because quality control is an issue. MOOCs, they're free. The hard part is finding the discipline. If you end up going with one of the routes that has long courses, finding the discipline to stick with it and then make sure that you apply it and aren't just learning pointless theory.
I know that's been a personal concern of mine, trying to stick with it as well as I'm learning my items there. Dan, thank you so much for your time. Been incredibly helpful. What a great way for us to wrap up our first day of Kaggle CareerCon. I want to note for those of you who are watching as well, if you are a part of the Kaggle Slack channel, we know that there's been a lot of issues trying to get connected. Frankly, we have to send out more and more links because so many thousands and thousands of you are signing up that we have to refresh that link every time we reach a certain limit. So please be patient with us. We'll be posting those as we get those updated. But Dan, again, thank you so much. Dan said that he'll be checking in over the course of the next few days, trying to answer a few additional questions that you may have. So continue asking those in Slack. Dan, thanks so much for now. We appreciate it.
Thanks so much.
To everybody else who is still on the call, finally concluding our day here is going to be our day one Slack mixer for job searchers. Not to be confused with our career and education fair that's happening on day 3, but this is basically your chance to get to know other attendees a little bit more, connect over common job search struggles, whether it be in your country or specific area of interest or an industry that you want to pursue further, and maybe even a chance to team up for future projects. So our CareerCon Slack community manager is Paul Mooney. Probably seen him throughout the Slack channel. He's going to grant everyone the ability to create their own interest-based or location-based channel, like hashtag Boulder, Colorado for me and Dan, for example, or hashtag bootcamp grads, or hashtag biotech, or any variety of interests or locations or things that can connect you together as a part of that mixer. And we're actually going to be awarding prizes to the channel creators with the most members. So we're going to conclude our day with that. Again, check out the job mixer that is happening, the job searcher mixer happening in Slack. We're excited to see what you come up with as you continue to meet each other and share your experiences. And as we sign off for today, you will see the schedule come up for day 2. We'll be kicking off things again tomorrow, right at 9 o'clock Pacific time, with our second API workshop with Rachel Tapman. And until then, thanks so much for tuning in. We'll see you guys tomorrow.